host device assignment. So Vladik, all yours.
Yeah, thank you, Pat. Yeah, so my name is Vladik. This session today, like we said, we'll have 2 parts. First, I would like to talk about host device assignment in KubeVirt, how does it work, and some of the recent changes we've made. And then we'll see a practical example how the Intel QAT device is being used in KubeVirt, and then perhaps we'll have some time for questions. So just a little bit of history. Some time ago, in a collaboration with NVIDIA, we have introduced the support for GPU and vGPU device assignment to KubeVirt using the NVIDIA QuickAssist device plugin. And what it does is that once this device plugin installed in the node, it would look up for all the NVIDIA devices on the host. And if bounded to VFIO driver, it will advertise these devices to the Kubernetes scheduler. And on the other side, when the user would request to start a virtual machine with the GPU assigned to it, it will have to post a virtual machine instance spec requesting this device, the desired device by its resource name. And this will result into a Virt launcher pod being scheduled in the node where where the desired device exists. And the device plugin in turn will allocate the device on the node and will move it into the container. It will also create an environment variable where it will reference the allocated device, either PCI address for PCI devices or UID of vGPU for mediated devices. And the name of this variable will be constant. It will be either GPU or vGPU pass-through devices. Then the Virt launcher will consume this variable, extract the device ID, and will form configuration for libvirt to start the VM. Now, this model works fine for allocating GPU and vGPU devices. However, it doesn't allow us to allocate devices which don't call themselves GPU. And we've received lots of requests for integrating different devices into KubeVirt. I've seen that every time that we would need to integrate a new device, this device will have to have its own variable name with its own prefix and its own handling code that would configure this device. This would create a lot of duplication and wouldn't scale for us going forward. Another issue with this model was that we couldn't correlate the allocated device to the API object specified on the virtual machine instance spec. Some of these devices, they require additional configuration to be placed in it, and as part of this model, we just couldn't do it. So we had to make a few changes and position ourselves better for the future. And we started with introducing a mechanism to allow administrators to have a better handling over the devices which are allowed in the cluster. And we'll talk about this in the next slides. We've also established an interface between the device plugins and KubeVirt. And we will require the device plugins to create a uniform variable names so for KubeVirt to consume. And then we generalized a lot of the device assignment process. Some of the code is shared now across the project. So here's an example of how the administrator can create a list of permitted devices in the cluster. It basically a list of IDs followed by a resource name of the device, and this list will have to be posted on KubeVirt KubeVirt CR to get this functionality enabled. And we spoke previously about the interface between KubeVirt and host devices. I'm sorry, and the requirement from host device device plugins now is to create an environment variable started with a prefix indicating the type of a resource. PCI resource for PCI devices and MDEV PCI resource for mediated devices. And this have to be followed by a resource name incorporated in this variable name. This will allow us to correlate the allocated device into the API object and post additional configurations such as ROM bar for devices that require that. Or even going farther, we can tag certain devices, and then using this tag, we could identify these devices and assign the guest to us for better identification or additional configuration inside the guest. And here's an example of how this may look like for certain devices. We spoke about generalization, and one of the things we've done in that area, we introduced 2 generic device plugins into KubeVirt. This basically allows us to, without adding any additional code to KubeVirt, to use any properly configured device on the node that was allowed by administrator in the cluster to be assigned to a virtual machine just out of the box without any additional steps. The way it would work is that KubeVirt will use the list of permitted devices in the cluster, and it would discover these devices on the nodes, and it will start a device plugin according to the type for these devices and advertise it to the Kubernetes scheduler. It will then, so these generic devices are basically anything you would expect from a device plugin to be. It handles the allocation and the accounting for devices and of course monitoring. So some of the vendor-specific device plugin, they provide additional functionality and additional features such as advanced monitoring and other features as well. And as part of this new model, KubeVirt will support external device plugins. This simply gets enabled by the administrator indicating that a given resource is being provided through an external resource provider on the list of permitted devices. What it will do, it will allow the device in the cluster, but KubeVirt will not attempt to start a device plugin for this device, and will expect the allocations to come from an external device plugin. And of course, KubeVirt will continue to support the NVIDIA QBirt device plugin. We'll just need to make some changes to this device plugin so it will use the new interface. But users who were previously using this device plugin, they will continue to do so in the future. Here's just a slide that shows how everything may work together. This assumes that the administrator has already posted a list of permitted devices in the cluster, and KubeVirt has started the generic device plugins on the nodes for the discovered devices. So in this example, the Intel QAT device is being provided through an external device plugin, but the NVIDIA Tesla T4 and the created vGPUs on Node 2 are being provided through KubeVirt device plugins. It doesn't have to be so, just an example. And we also see that the users has already posted a spec requesting certain devices to be attached to their virtual machine. And this resulted in the Virt launchers to be being scheduled on the nodes where the desired devices are actually exist. And on their turn, the device plugins will allocate the devices and move them into the Virt Launcher compute container. But we could see the environment variables that these device plugins will form according to the new interface, indicating the type of resource and the resource name incorporated inside the environment variable. This will be consumed by Virt Launcher, which will in its turn form a configuration for libvirt to start the virtual machines. This practically concludes my presentation. I'm sorry, I probably forgot half of the things that I want to say, but that's it.
Okay, I will, there is a second part of the presentation, which is Leo's recording of his use case, which I'm going to stream here. So okay. I'm sorry, my video player crashed just when I hit play, which is a bad time to crash. So just give me 1 second. Okay, second try now.
Hello everyone, my name is Yao Le in Chinese, and my given name is Le. You can call me Le, yeah. I am a cloud software engineer in Intel's SSE team. First, I'm sorry for my absence for this meeting, because there is the Spring Festival here and I have a lot of things to do at home. So I decided to join the summit using video record after discussion with the community. Let me begin my session then. My topic is VNF and CNF acceleration, especially VNF acceleration in KubeVirt VMs. First of all, I would like to introduce the project that I'm focusing on and why we chose to integrate KubeVirt. Next, I will introduce the user cases acceleration of Intel QAT used in the project and how I use the KubeVirt new API provided to implement PCI passthrough of QAT devices. Finally, I would introduce the performance after integrating KubeVirt with QAT. My correct focusing on project is Aquino ICN, short for Integrated Cloud Native NFA Application Stack Family. It can be considered as a resource orchestrator. It intends to address development of workloads in a large number of edge and clouds. It can integrate infrastructure orchestration to ensure the requirements of edge cloud services are installed and controlled. And it is a cloud-native compute and network framework to integrate NFA application to de facto standard and setting framework to address 5G, IoT, and various Linux Foundation edge use cases in cloud native. Why we chose KubeVirt in Aquino ICN? Because in ICN cluster, we need to manage the VMs like a plan pods, and VM should be integrated into Kubernetes cluster. And we need to enable the standard Kube controller commands to manage KubeVirt VMs. And there are some workloads need to be run in VMs. Installation required in some use cases. It's better to use VM, yeah. So after investigation, we chose KubeVirt as VM managers in SCN. Why we use the need the QAT PCI device to do acceleration? Because the software defined adage 1, it is a project in SCN, and I'm focusing on it. It is a solution to enable SD-WAN functionalities include multiple WAN link support, WAN traffic management, NAT, firewall, IPsec, and traffic shaping, with focus to address the challenge when applying on edge computing environment, like resource limitation, no public IP, and edge overlays, traffic centralization, automation, and other cases. So it has below components, CNF and VNF, CRD controller, and a central controller to control these edge cases, edge clusters. And then I will give a brief introduction to Intel QAT PCI device. It's short for Intel QuickAssist technology and is a generic PCI device. You can find more information on this web link. And QAT can be involved in the IPsec implementation to ease the workload of CPU on data encryption and decryption. It can be invoked through the DPDK CryptoDAO API, Linux kernel crypto framework, as well as OpenSSL. Yeah. It can offload the specific workload from CPU to QAT. It makes it easy for developers to integrate accelerations in their design. It can increase the business flexibility and reduce the demand on the platform, especially CPU utilization. Why we use it in the SD-WAN? Because in SD-WAN, we need to build up a kernel-based IPsec acceleration by QAT VF in container in VM. Their VM launched by KubeVirt, yeah. And the VPN established the required confidentiality, integrity, and authentication through cryptography. So the QAT can accelerate this workload. And in SCN, IPsec is used to connect different edge nodes and traffic hubs through WAN. Because of different scenarios and requirements, both CNF and VNF are needed in SCN. And to maximize the CPU utilization, we need to offload the workload from CPU to QAT. And SCN uses OpenWRT. It uses strong WAN to build up the IPsec. So in KubeVirt VM, we need build the strong WAN and IPsec with QAT acceleration. Before KubeVirt release version 0.36, if you want to use your generic PCI device, you need a lot of code work to do. First, for example, QAT, we need to build the Intel QAT driver on host and configure host LMU group and find the BFIO PCI driver for QAT cluster, QTVFS, and deploy the Intel QAT device plugin in DPDK mode in cluster. And there are a lot of code work to do to add functionality to KubeVirt to handle the QAT device assignment. This is the PR I have submitted, and no, I think we don't need it. Yeah, and we need to configure the KubeVirt PR to create a VMI with QAT fields specific and launch a VM with QAT VMS in it. It has a lot of work to do. So after KubeVirt release version 0.36, there are two ways for us to use the UCL device. One is for the Kubernetes device plugin, and another is the KubeVirt internal device plugin. Using your own device plugin, for example, QAT device plugin, we need the device plugin config specific container environment value in the container runtime. It will used in the KubeVirt API, yeah. And we need band VFIO PCI driver to Intel QAT VF and configure KubeVirt there to accelerate the external device resource. it's posted, the resource name is it's posted by the QAT device plugin, yeah, and config host devs field. Another way is a very simple and recommended way is using the KubeVirt internal device plugin. We don't need any other PCI device plugin to develop. What we only do is to configure the environment, like bend the VFL PCI driver to your device and configure the whitelist host device. Then we configure the host devs field in your config YAML field. Yeah. So we have launched a KubeVirt VM to do some testing. First, for OpenSSL, we can see the algorithm is RSA, ECDSA, and AES. And the software is only run by CPU, and the async is with the QAT device. We can see in the 16 kilobits, we could have 6 times better performance. And yeah, the sense very fast with QAT is a better performance than only run by the QAT, run by CPU software. Yeah. And for IPsec, we launched 2 KubeVirt VMs and one for server, one for client. We assign 2 QAT VMs in the KubeVirt VM and use run1 to establish the IPsec. And the proposal is AES. This yeah. And using the Linux kernel crypto framework. So when we build the QAT VFs driver, we need the some feature enabled. Yeah. The testing tool is IPF3, and this is for the QAT down. This is for QAT up. This is a detailed result when testing on the CentOS 3, CentOS 7, and Ubuntu. We can see when QAT up, the bad ones have almost 2 times of QAT down. So we can say it has a better performance when using the Intel QAT VF in the KubeVirt VM. And then I'm sorry for my absence again. So if you have some questions, you can connect communication with me using my email, le.yao@intel.com, and for detailed information, maybe, yeah. Okay, that's all. Thank you.
Okay, so I guess now it's time for questions. There was a question raised in the chat that because the chat will disappear after the event, if you don't mind, Nicola and Vladik, I will repeat the question again here live. So you can probably, Vladik, answer it and elaborate a bit more. So Nicola was asking, in the example slides with 2 nodes, could we specify the GPUs as host devices rather than GPU? And if not, why? Thanks.
So do you want me to repeat the answer? It's just, yeah, this will be honored in both of the fields. It's possible. It's just some people are more comfortable with requesting GPUs directly. But yeah, it can be posted in both of these fields.
Okay, yes, thank you. And yes, I wanted to repeat the answer because otherwise it is not recorded. Let's say the chat is not part of the recording. So now we can see for the benefit of whoever is watching the recording. Okay, are there any other questions for Vladik here? Or okay, I see a question from Sheng. Is there a performance difference between requesting the GPU directly instead of host devices?
Oh, it's exactly the same functionality. It's just a different API field.
Okay. Okay, those were the questions so far. As a reminder, you can follow up with more questions if needed in the Kubernetes Slack in hash virtualization. I haven't seen that. I was checking a while ago. There were no questions for this. No. Okay. Well then, thank you very much, Vladik, and thank you very much, Le, who could not join us today, but did a great effort to record and share the recording. Thank you both, and see you in Slack.